Let's talk about electricity. You think you know what it is, don't you? I mean, you use it constantly. Right now, electrons are flowing through the device you're reading this on. Electricity is powering the lights around you, keeping your food cold, charging your devices. It's everywhere. So you must understand it, right? Okay, explain it to me. What happens when you plug something in? Where does the power actually come from? What is electricity at its core? Most people say something vague. It's energy. It's electrons moving. It's current in a wire. But here's what bothers me about those answers. They don't actually explain anything. They just rename the mystery. Sure, electrons are moving, but why? What's pushing them? And why does that pushing create light or heat or motion? The truth is darker than you think. The thing we call electricity is deeply, profoundly weird. And the way we teach it completely hides that weirdness. We make it sound normal, predictable, safe. But once you see what's really happening, once you peek behind the curtain, you realize that we're manipulating something absolutely extraordinary, something that breaks everything you think you know about how the world operates. Let me show you what I mean. Here's an experiment, simple one. Take a piece of plastic wrap, rip off a strip. Now rub it between your hands really fast, like you're trying to warm them up. Now hold it near the back of your hand without touching. Feel that? The hairs on your arm are moving, standing up, reaching toward the plastic. You can actually feel the plastic pulling on you from a distance. Stop and think about that for a second. You rubbed plastic. That's it. No batteries, no wires, no power source, just friction. And now that plastic can reach across empty air and tug on your body. How? In your normal experience of the world, things only push or pull when they're touching. You push a chair, you touch it. You lift a book, you touch it. Forces require contact. Except here's a piece of plastic, not touching you, pulling on your arm hairs through empty space. Most people shrug. Static electricity. We learned about that in middle school. It's not important. Not important? You're looking at the force that holds every atom in your body together, the force that makes chemistry possible, the force that allows your neurons to fire, your muscles to contract, your eyes to see. You're looking at one of the four fundamental forces of the universe, demonstrating its ability to act across distance. And you think it's a parlor trick? This is the problem. We've become so familiar with electricity that we've forgotten how absolutely insane it is. Let's break down what just happened. When you rubbed that plastic, you scraped electrons off your hands and piled them onto the plastic. Just a few trillion extra electrons. And here's the thing that's going to break your brain. Those excess electrons despise each other. They push away from each other with a force so large you literally cannot comprehend it. Let me try anyway. Take two electrons. Place them 1 centimeter apart. The electromagnetic force between them is about 10 to the 42nd power times stronger than the gravitational force between them. 10 to the 42. That's 1 followed by 42 zeros. The electromagnetic force is so incomprehensibly stronger than gravity that gravity might as well not exist. For electrons, gravity is irrelevant, meaningless. Electromagnetic forces are everything. So here's the question. If these forces are that monstrously strong, why isn't everything exploding? Why doesn't matter just tear itself apart? The answer is almost magical. Cancellation. Think about what an atom actually is. At the center you've got protons with positive charge. Around that you've got electrons with negative charge. Positive and negative, plus and minus. And these charges follow one simple rule. Like repels like. Opposites attract. The forces are exactly equal in magnitude. The push of repulsion equals the pull of attraction. So in normal matter, you get an intimate mixture of positive and negative charges, protons and electrons, packed as close together as physics allows. Every positive charge is surrounded by negatives. Every negative is surrounded by positives, and they balance out. The enormous repulsive forces are canceled by equally enormous attractive forces. Everything is neutral. The forces are still there. Those monstrous electromagnetic forces are still acting, but they're balanced so precisely that the net effect is zero. And because the forces are so huge, even the tiniest imbalance creates effects you can feel. When you rub that plastic wrap, you move maybe 1 electron in every trillion. That's essentially nothing, but it's enough to make your arm hairs stand up. Because when the underlying forces are that enormous, even the smallest excess creates a noticeable effect. This changes everything about how you think about matter. Pick up a mug, hold it in your hand. What are you feeling? You think you're feeling the solidity of ceramic, physical substance. Wrong. You're feeling electromagnetic repulsion. The electrons in your hand are pushing away from the electrons in the mug with enormous force. The reason you can't push your hand through the mug is because the electromagnetic forces are so strong that the electrons refuse to overlap. Your hand never touches the mug. Not really. There's always a tiny gap between the atoms in your hand and the atoms in the mug. You're not feeling contact. You're feeling the electromagnetic force pushing back at you. And here's the thing that should completely restructure your worldview. All forces you've ever felt are electromagnetic. Every push, every pull, every sensation of touch or pressure or resistance, it's all electromagnetic repulsion and attraction acting at a distance. You have never touched anything in your entire life. Every time you think you're touching something, you're feeling electrons pushing away from electrons through empty space. The same force you saw with the plastic wrap, just acting at smaller distances where the forces become enormous. Now let's talk about wires. You've got a copper wire stretching across your house. At one end there's an outlet. At the other end there's a lamp. You flip the switch, the lamp lights up instantly. What just happened? The standard explanation is that electricity flows like water. Electrons enter the wire at one end, travel down its length, and emerge at the other end. That explanation is completely wrong. Electrons in a wire move incredibly slowly, about 1 millimeter per second. At that speed, it would take nearly half an hour for an electron to travel across your house. But the lamp turns on instantly. So what's really happening? Here's the key. The wire is already full of electrons. Copper has lots of free electrons just sitting there, ready to move. When you close the switch, you create a voltage difference. That voltage pushes on the electrons at one end of the wire. But because electrons repel each other across distances, that push immediately affects the next electron, which pushes the next one, which pushes the next one. It's like a line of people standing shoulder to shoulder. If you push the person at one end, the person at the other end feels it almost immediately. Not because the first person walked down the line, but because the push was transmitted through the crowd. The push travels through the wire at nearly the speed of light. Not because individual electrons are moving fast, but because the electromagnetic force acts instantaneously across distance. That's what makes electricity useful. You can push here and something responds there, almost instantly, across huge distances. But where does the push come from? Let's trace it back. Your lamp connects to an outlet. The outlet connects to wires in your walls. Those connect to power lines, and those connect to a power plant. Maybe it's miles away, maybe 100 miles away. And at that power plant, something is spinning. A massive turbine weighing tons, rotating at thousands of RPM. And that spinning motion, happening miles away, is what's powering your lamp. How is that possible? The connection between that spinning turbine and your lamp is magnetism. Electricity and magnetism are the same thing. They're not two separate phenomena. They're two aspects of one unified force, the electromagnetic force. Moving electric charges create magnetic fields. Changing magnetic fields create electric currents.